So we are going to be assessing so with the weight and balance test, we are going to discover if we can find the CG with the overall mass of the aircraft. This is done with knowing the weight in the landing gear and with the weights on the tip of the aircraft. Take a lot of data sets, so then when we build the plot, we can discover if it's suitable or not. As we can see from the points taken, we can actually very well say that the CG can actually be determined using the weight of the aircraft with more or less a good degree of precision. The second test is a thrust test. In this one, we are going to verify if the RPM and the thrust which we are getting, it's good enough. And the same thing, we take a lot of data sets. So we take a lot of points. As we can see, the actual force and the measured force don't really coincide that much, so there will be some adjustment need to be made. Then we move to the sector control. In this one, we're gonna try to see if the aircraft is well programmed. So if I put the aircraft to the left, it will go to the left. If I put the flaps down, the flaps will be down. So the first thing we did was a roll. Now we're doing the pitch. Afterwards, we will be doing the yaw. And in the end, we'll do the flaps. So always we verify twice if we're doing the right thing. In this case, in the flaps, we made a mistake, so we need to amend it straight away. Now we move on to the dynamic control test. The first thing I'm going to do is see whether or not the static control response was well done, because now we can see the aircraft actually moving. We can see that the main ones are very well done. As we can see, the roll as well, it's maintained quite well, which means that there will be a small damping effect. We're going to see the change in the CG. This will allow us to determine the longitudinal dynamic response. Also, in this one, we varied the CG and the wind so that the aircraft can be in V-stall. As we can see, if we put the aircraft going too far, if we put the CG too far, in or out, the aircraft will be uncontrollable. With this testing, we can see that the best CG will be at 0.75, so 35% of the Mach. Also, we assess the elevator trim. This allows us to verify the longitudinal dynamic response as well. As we can see that if we put the trim too far, the aircraft will pitch down, up. This is too bad. So also, as we could have seen with the CG, if we put the thrust too high, the aircraft will naturally pitch down as the engine is up than the CG, so there will be more momentum. Now we move on to the wind tunnel test. In the wind tunnel test, we will have we'll be able to have data sets. We just configure it as we want. The majority of the data was already very well done. Then we just run it. This is where we get the raw data. Of course, this is not acceptable in order to read and understand. So we did this data analysis. As you can see, after 15 degrees of the angle of attack, we will see that the aircraft will stall. As predicted, the flaps increase the coefficient of lift, but as we can see in the draw propeller, the coefficient of drag also increases for the same amount of coefficient of lift. So there is a small trade-off. And then when we are assessing the alpha versus the ratio of lift and drag, we can see that with flaps at 40, we will get a better LD for a fewer slaps, for fewer angle of attack. Also, assessing the momentum around the aircraft. If the elevator is too far, it will do a down momentum, so it will nose down. So we need to put the elevator. As we see, the elevator at 0 will not be good, as it's above 0. So we'll need to set it just a little bit above. Also, if we change the CG, we can get a more stable aircraft or a more unstable aircraft. From the data, we can see that the 0.075% of the Mach will be the best position of the CG. One thing that we can see as well from the free flight is that if we put the RPM too high, the aircraft will drift. As we can see, since we set the aircraft with the parameters which we already analyzed in the wind tunnel and the other ones, we will get a good flight, stable one, in which we can do a lot of things. This aircraft is naturally stable, so it's a very well built aircraft.